Right now, as you watch this video, billions of pulses of light and electricity are moving across the planet at nearly the speed of light. They are traveling through cables at the bottom of the ocean, bouncing off satellites in space, and pulsing through the air around you. We take the internet for granted, but the journey from a simple copper wire to a global quantum grid is one of the greatest engineering feats in human history. Today we are tracing that evolution. We've categorized every major internet connection type into 7 levels of speed and complexity. We start at level 1 with the screeching sounds of the 1990s, and we end at level 7 with a technology that feels like science fiction. If you want to understand the invisible web that connects our world, you need to see all 7 levels. Let's plug in. Level 1 takes us back to dial-up. In the early days, we didn't have dedicated lines for data. We had to hijack the existing telephone network. When you went online, your modem literally made a phone call. It translated digital data into audible sound frequencies, that famous screeching noise, and sent it over copper telephone wires. This process is called modulation and demodulation, which is where the word modem actually comes from. The speed was capped at 56 kilobits per second because the phone lines were designed for human voices, which only require a very narrow frequency. If you try to download a single 5 megabyte song today on a 56K modem, you would be waiting for over 12 minutes. And because it used the actual voice line, your mom picking up the kitchen phone wasn't just an annoyance, it physically severed your digital handshake, forcing you to start your download all over again. The speed? A measly 56 kilobits per second. To put that in perspective, downloading a single high-quality photo today would have taken you 10 minutes back then. And the biggest catch? If someone picked up the house phone to make a call, your internet connection would instantly die. Level 1 was slow, noisy, and fragile, but it was the first time the world truly started talking to itself. Level 2 is DSL and broadband. Engineers realized that copper phone wires could actually carry much more data than just human voices if they used higher frequencies. DSL, or digital subscriber line, allowed us to use the internet and the phone at the same time. This was a revolution. But here is the part most people don't know. DSL is asymmetric. That's why your download speed is always much faster than your upload speed. It was designed this way because in the early 2000s, people were mostly consuming data, not creating it. However, DSL had a massive flaw called attenuation. Because electrical signals weaken as they travel through copper, if you lived more than 3 miles away from the provider's central hub, your high-speed internet would crawl at a snail's pace. This created a digital divide between cities and rural areas that lasted for decades. Suddenly, we weren't calling the internet, we were on the internet. Speeds jumped from kilobits to megabits. This era gave birth to YouTube, early social media, and the first wave of digital creators. But DSL had a major weakness. The further you lived from the provider's office, the slower your connection became. It was a local solution for a global problem. To go faster, we needed a different kind of wire. We needed level 3. Level 3 brings us to fiber optics. This is where things get fast. Instead of sending electrical pulses through copper, fiber optics sends pulses of light through strands of glass as thin as a human hair. Because light travels so much faster than electricity, and because glass doesn't suffer from electrical interference, fiber can carry massive amounts of data over incredible distances. This is the backbone of the modern world. In fact, over 95% of all international data travels through subsea fiber cables at the bottom of the ocean. These cables are wrapped in steel and buried under the sand to connect continents. When you send a message from New York to London, it's traveling through a glass tube at the bottom of the Atlantic. Level 3 is the physical foundation of the global web. But what happens when there are no cables? That's level 4. Level 4 is wireless and cellular data, 4G and 5G. This is how most of us consume the internet today. Instead of being tethered to a wall, we use radio waves. Your phone is essentially a sophisticated radio that communicates with a network of cell towers. The move from 4G to 5G wasn't just a small step, it was a leap into millimeter waves. These waves are much higher frequency, meaning they can carry significantly more data, but they have a short range and can be blocked by something as simple as a tree or brick wall. To fix this, 5G uses small cells, thousands of tiny transmitters placed on light poles and buildings. This allows for massive MIMO, where a single tower can talk to hundreds of devices simultaneously without the signal getting congested. This is why you can now stream 4K video in a crowded stadium where 4G would have completely failed. It's not just more speed, it's more capacity. These high-frequency waves allow for ultra-low latency, meaning the delay between your click and the server's response is almost zero. This is what makes self-driving cars and remote surgery possible. But radio waves have a limit. They can't travel through mountains easily, and they don't reach the middle of the desert. For the truly remote parts of the planet, we have to look up to level 5. Level 5 is satellite internet, and specifically LEO, low Earth orbit, constellations like Starlink. Traditional satellite internet was slow because the satellites were 22,000 miles away in geostationary orbit. The signal had to travel so far that the lag was unbearable. At that distance, the round-trip time for a signal was over 600 milliseconds. Level 5 solves this by bringing the satellites down to just 340 miles. But there's a catch. Because they are so low, they are moving incredibly fast, about 17,000 miles per hour. They fly across the sky in minutes. Your ground dish has to use phased array technology to electronically steer its beam and hand off the connection from one satellite to the next without dropping a single packet of data. It is a constant high-speed relay race happening above our heads every second of the day. Level 5 changes the game by launching thousands of small satellites just 300 miles above the Earth. This creates a mesh in space that covers every square inch of the planet. Whether you are in the middle of the Amazon rainforest or on a boat in the Pacific, you can have high-speed access. We are finally closing the digital divide, ensuring that no matter where you are born, you have access to the world's information. But even satellites have limits. To reach the next level, we have to move beyond hardware. We have to look at level 6. Level 6 isn't about the wire, it's about the logic. This is SD-WAN and edge computing. In the past, all data had to travel back to a giant central server, usually thousands of miles away, before coming back to you. This created latency. Level 6 solves this by bringing the internet closer to you. Companies are now building edge servers in every major city. When you watch a Netflix movie, you aren't streaming it from California. You're streaming it from a small server box just a few miles from your house. By moving the processing power to the edge of the network, the internet becomes virtually instantaneous. It's no longer a slow conversation, it's a real-time experience. But there is one final level that changes everything we know about physics. We have reached level 7, the quantum internet. This sounds like science fiction, but it's already being tested in labs today. It uses a phenomenon called quantum entanglement. In this state, two particles become linked so that whatever happens to one happens to the other instantly, regardless of the distance between them. In a standard internet, data is a bit, either a 1 or a 0. In a quantum internet, we use qubits. Because of a property called superposition, a qubit can be both a 1 and a 0 at the same time until it's measured. This allows for quantum teleportation of information. Because the particles are linked across space, the transfer of state is instantaneous. There is no travel time. Furthermore, it is the ultimate security. If a hacker tries to intercept a quantum signal, the act of observing the particle collapses its state, instantly destroying the data and alerting the sender. It is a self-destructing, unhackable, instant web. A quantum internet wouldn't just be fast, it would be instant. There would be zero lag between Earth and Mars. Furthermore, it would be unhackable. Because of the laws of quantum physics, if someone tries to observe or hack the data, the particles change state, alerting the sender immediately. This is the end game of connectivity. Today, we live on levels 3 and 4, but level 7 is the future of the human species. If you want to stay updated as we move toward level 7, hit subscribe. This is the Explained Learner, and your journey has just begun.